Cool. I'm Renan, and I'm going to be talking about Elm. So the purpose of this talk is just to really just give like a brief intro to Elm and try to sell you on the idea that you should consider it for your next project in place of something like React or other tools we've been using. I have worked with Elm before. I have seen it in production. I have built and maintained about 3 or 4 different websites using Elm. But most of that experience is with Elm 18. Although I do have some experience with Elm 19, it's mostly like just from studying and personal projects. But there isn't a huge difference between the two other than tooling. So yeah, okay. So let's talk about the what's currently trending in terms of technology on front end. We have React, Redux, TypeScript, and to an extent, functional programming, and friends. So I know that of course there are other trends other than this, but for the purpose of this talk, I think these are the interesting ones to mention. Recently with React and Redux, we have been learning a lot of new concepts and approaching new ideas to front end, such as immutability, pure functions, single source of control, approaching this, this model of a unidirectional flow of data in a front end. And those ideas, the solutions brought by Redux, brought by React, the same ideas were designed into Elm as a language. And so the point I'm trying to make here is that if we want to evolve further, if we want to continue solving these problems and more, Elm makes sense as the next step. And I also put TypeScript here because since it's very popular now, people have been using, we've been bringing types back to the table, and after so long working with JavaScript with no static typing, so I believe this also increases the reasons. If people are enjoying TypeScript, it's one more reason for them to consider Elm. And also the shy attempts at functional programming in JavaScript. So this brings us to Elm. There are a lot of different ways to describe Elm, but this is something I thought, and I think it's a very simple way to describe it. It's basically a language without this, the first image, and without this. So what I mean by this, that's a language where you won't need to know what a functor is. You won't need to know what a monad is. You won't have to read 10 different monad tutorials to start learning Elm. And that's one of the things they thought when they were designing Elm. They wanted to be really approachable and easy to begin with, like JavaScript, because they thought that that's where most of the appeal of JavaScript comes from. You can just open your browser and open DevTools and start typing JavaScript. So they thought that languages like Haskell, as cool as they are, they're not very easy to start with. And I have personally felt that. So I really believe in that, in this idea, because especially their tooling is very obscure. It's very hard to learn and to get started with. So Elm, on the other hand, makes it very easy. And on the other side, what we have is basically a JavaScript exception. I'm sure you've all seen this before. And what I'm trying to say with that is just that it's a reliable language. It's a pure language, so you have the insurance that you won't have issues like this in runtime. So basically that idea that if it compiles, it works. I mean, you still might get the logic wrong, but it works. So talking about benefits of Elm, this is one of the big words that people usually talk about when it comes to frameworks and front end, the performance. So I put two graphs here. One is about the runtime performance, so rendering things, and the other one is about the page load time, so the page load time performance of a Elm application. So in the runtime here, you can see that the shorter bars are the better. So they're measuring the time it takes to render the same thing in these different technologies, both in a naive approach and being optimized. You can see that Elm really does best here, and that's because they have their own implementation of a virtual DOM. And I don't really know the specifics, but I know that since it's a pure language, they have some guarantees that allow them to run a lot of optimizations that the other frameworks don't have. So that's the reason. And there's a blog post on their website. You can see, I think it's the link is in the very first page, and it talks about this more in detail, and it's pretty interesting. And on the other side, we have the load time. The assets generated by a Elm application are very small because they have by default the feature of dead code elimination. Because since it's a pure functional language, you can by default just import and compile what you need. It's kind of like tree shaking, but tree shaking still has a lot of issues. For example, Webpack supports it, but not all JavaScript modules support it. If your module has a side effect, that is, if you import it and it's like, I don't know, launching a rocket or increasing a variable somewhere, that module has to be marked as having a side effect, and that already discounts it from tree shaking. And modules that are very popular and widely used, like Moment.js, they're not tree shakeable. So those are examples of like tree shaking doesn't do it all still. And Elm has this by default for every package. So it's pretty cool. Not sure if you guys have any questions so far.
No.
Okay.
Everything will.
Okay, tooling and ecosystem. I don't have pictures for this one, but I just put a list here and something I thought cool about each one of them. So we have packages which have enforced semantic versioning. Again, something that's only possible since Elm is a pure language, because I have the experience of publishing a package myself. It's a very small one, just really to learn about it. And every time you change your public API, every time you remove a function or you add a new function, and it changes in a major way, as described by semantic versioning, they will force you to bump it in a way that describe that change. So it's impossible for you to update a library that has a new patch version, for example, and something suddenly break in your application. And I think that's pretty cool. Another thing is the Elm CLI, the command line tool. It's official and it's really helpful. It has basically everything you need to get started. No need to install anything else. The only other thing you will probably like to install is Elm Live. It's sort of like a replacement for Create Rect App. In place, you might use Elm Live that allows you to have a development server running that will, react to changes and reload the website. With Elm Live, there's the Elm debugger. It's kind of like Redux DevTools. You have all the messages that are passing, and you can time travel, and it just works by default. And it's pretty cool. And also we have Create Elm app for those who are very used and very much into Create Rect app. It's a fork of Create Rect app, but using the Elm Webpack Loader, and it also works pretty well, but I wouldn't recommend them as much because they don't receive as much support, although when I used them, they did work fine. And now I want to go over the Elm architecture. So it's pretty simple. We have here Elm, which would be kind of like the store in Redux. So here we have the global state of the application. Here's where all the impure things, all the impure world exists. So here's where there's the virtual DOM, doing the diffing and patching in the DOM, and running all the side effects. And through the model, we will render HTML. So we'll render what we see based on the state of the application at a given time. So we get the application, and through user interactions, we dispatch messages that are kind of the equivalent of Redux actions. Along with these messages, we might or not dispatch comments, which are basically descriptions of impure actions. And these comments, for example, calling an HTTP request will be ran inside the Elm runtime, and then new messages are going to be created. So you get the results of those effects. And that's pretty much essentially how it works. So we have a model, we have a view, and we have an update function that is kind of like a reducer. And now we can see it in action. I don't have much else in the presentation, so let's just go for it. So I have the Elm command line here. First, you guys have any questions about the Elm architecture? I'm gonna still go through it with the code, but just in case.
No, maybe I was late. I didn't take, if you create the HTML and then inject this JavaScript, or it's like a JSX for React. Do you have a language for that though?
Oh yeah, okay, so on that, it's not really like JSX. It's just a bunch of functions, but it's still, yeah, in some sense, it's pretty similar to JSX, but no, it's not like an extension of the language. It's just the language itself.
Oh, okay.
But we're going to go through it, so we'll see it in action. Okay, so we have the Elm command line tool here. We have a REPL, good to play around and just try to run some small snippets. We can initiate new projects. There's the Elm reactor here. I'm going to show it later. So we can compile files to install packages. This is used to bump your package version. That's what I mentioned with the semantic versioning. This is used to diff Elm packages versions. And let me just show you here real quick. Yeah, this is a cool one. So here I'm diffing two different versions of the same package by this guy here, HTTP extra. And it's showing me what was added. So we have this new type here and a new function called expect no content. And this other one was removed. So that's why this is a major change. So this is a really cool tool you can use to update your packages and just be aware of what's going to break. So let's start a new project here. Elm T. And let's run Elm init. So it's going to generate a Elm JSON file, kind of like a package JSON. Just open it here. So if you guys use VS Code, there is a VS Code extension. It works pretty well. Wait, it didn't create the file. Did it open the wrong place? No. Okay, cool. So we have it here, essentially like a package JSON, not a big deal. So let's create a new file here. main Elm. So I'm not gonna write all the code. Let me just grab an example here and you can see it working. This is a very basic example. So we have here the model. That's just an integer. We have the messages and the update. So sort of like you can think of it like redux actions and the reducer. So when we're sending an increment message, we just increment the model, otherwise we're decrementing, and that's basically about it. And here we have the view. So this is where we would have our JSX. It's not really JSX. These are just regular functions. So you can compose them and use them with other functions like a normal function. And that's, I think, one of the things it has that's better than JSX, although obviously JSX syntax is closer to HTML. So let's see it working. We can use Elm Reactor for this. It's going to open here. So this is Elm Reactor. We can like compile single files and see the application. Let's open this guy here. Very simple example, counter. So let's stop this. Let's use Elm Live instead. Elm Live, and I'll give it the debug. Oh, I have to put the entry file. Source. Oh, this is a bug that happens after I run the Elm Reactor and then run Elm Live for some reason. Let me just see what's going on. I think I have stuff here. Let's just delete this. I was practicing this yesterday and I found this very weird bug, but I have no idea what it is. Okay, good. Cool, so we have the debugger now. So when I dispatch actions here, you can see it's incrementing there. So I can open it. It's not a browser extension. It's just a new window and it's embedded in your application.
Nice.
I can time travel. So you can see that as I click the actions, it goes to that state when the action was dispatched. You can see it changing back there. And you can basically see the message and the model. Usually your application's model is more complex, so you'll see this big JSON here, but since ours is just a number, that's all we get. So,
Cool.
Do you guys have any questions so far?
So could we see the HTML page? Like how do you insert the compiled code? That would be great. So what happens inside that HTML file? I'm not sure if I'm clear.
You mean here, this file here?
Yeah.
Oh, this is just the compiled version. This is not something we really have to worry about. This is like a generated asset that we'll deploy. This is just the deployable part. We don't really have to worry about it in a real application. This is going to get ignored, and we don't ever touch this. Okay. We can still write JavaScript. This is not something I went through, but you're not technically obligated to just use Elm modules. You can use JavaScript npm regular modules by using the JavaScript interrupt. So you can create this separate JavaScript module, and you can send messages back and forth that are actually subscriptions to communicate with your Elm application. But it's still very it's very constrained. It's not like it's all. For example, it's everything that comes from this outside JavaScript world is asynchronous. So they put a lot of constraints on that because they didn't want your application to be like half Elm, half JavaScript. The intention is really for Elm to take over and own the whole application. So let's go over a more complex example here. Let's take a module. This is the official package module package website. It's pretty cool. All packages, they have to create modules in this format. This is also another thing that besides semantic versioning that is enforced, is that you have to write documentation for all the public functions, and they all have the type signatures here. So it's really helpful because all the packages are in the same standard. So most of the times you have the information you need and examples to go over. So let's take this example here.
I have a question in the meantime, Renan. Maybe you're not right. How is the normal structure of the files? It's like you have everything in one single file, or you can you know, do a scaffolding, something like that, like views, models. Oh,
so
you got it?
Yeah, usually there isn't like a standard way of doing it, but there are different patterns. Usually what people do, it's just they take these three main components from the architecture, so model, view, and update, and they go creating smaller submodules of them. So you have the main model, you have the main view, you have the main update function, but you also have the same thing for, say, the authentication module. So you have the authentication module, which has its model, update, and view function. Sort of like components, but they're usually bigger, and they own their own state. And since all these modules are, then they get composed into a bigger version of the whole architecture. But really, you can do it any way you like.
Yeah, I'm asking because I'm super new with this, so it's like very good. But
yeah,
for me, I mean, for the first view, it's like a lot of code, you know. Okay, I got it.
Yeah, no, this is like a normal concern people have, and there's a talk about this, about how like modules work, and you know, how to get used to this by Evan, the creator of Elm. It's pretty good. It's pretty good. It's one of the references in the end of the video.
Okay,
in the end of the presentation.
Thank you.
So let's just paste this example here. We won't need this. We won't need this. So let's just grab this here and put it here. So our new message is only one. That's got book. This is a message will get dispatched after the request has been completed, and it contains a result that's either an HTTP error or a string. So we're going to fetch a string. Let's create a new message. It's called fetch book. Let's update our model. Book, and this is got book. So we'll have to update our whole application. Now this, instead of a sandbox, it's a simple version. We have an element. So in an element, let's update the whole thing. So our model now will be a maybe string. So maybe is a type that might be there or might not. So a maybe is constructed like this. It's either a just something or nothing. So it's kind of like a nullable type. I think in some languages it's an optional.
That's amazing.
Hey, Demi.
While working for Disney, we used to wait for a maybe on that project because we only have a goofy to show when something wasn't working. It's amazing.
So let's start the model as a nothing. Of course, there are more expressive ways to do this, but just to be simple, let's use a maybe. And here now a model or update function to return not just the model, but a model and a common message. So cool. When we fetch the book, we want to keep the same model, and we want to get book. It's a comment. When we got the book, let's do some pattern matching here. We want only to deal with the case if it's a okay, which means the result it's a good. It has the value we expect. So if it's a good text, our model will be just that text, and we won't be dispatching the comment here. Otherwise, in all other cases, we could handle the error, but I'm not. So let's just ignore it and say that it's nothing. So in this case, we won't get the text. In this case, it's just the text. Cool. Now let's update our view. So our view will be just a button to fetch the book, fetch, and then let's do some pattern matching. So model case of, it's just content. We want to read a pre, the text, content. If it's a nothing, let's just render nothing. So probably have to update some things. Yeah, I have to update this. So this now receive the initial flags of the application. And a command message. So this and command none. This is called when the application starts. Oh, it's missing HTTP. I have to install it. So let's just install it. It's actually telling me here that the module doesn't exist, so I can just copy this, install it. Yes, so this is the package.
What's the meaning of the, sorry, what's the meaning of the just keyword?
The just keyword, like types in Elm, this is a, what we call a union type. Let's say this is the number type. It doesn't exist, but let's say it is. And it's basically a sum. So I'm just describing all the ways to construct this type, this value. So a number can be a 1 or 2 or 3 or 4 and so on and until, you know, infinity. So I'm saying this is my type number and these are all the different ways to construct it. A maybe, on the other hand, has only 2 different type constructors. And it takes a type as an argument, kind of like a generic argument. So a maybe, it's like this, takes a type and tells me that it's either just that or nothing.
Oh,
So it's a value that can fail, that might not be there. And of course, Elm forces me to unwrap that maybe every time I'm going to use it. So I don't get, for example, in an imperative language, I would get a no reference, no pointer.
It's like an option in Scala, maybe.
Yeah, it's basically the same as an option, an optional. So HTTP installed. I think it's going to work now. Let me see here. Oh, it's fetch book, fetch. Okay. I have to import this as well. Usually the HTTP module will just import everything. And also have to add the subscriptions here. Subscriptions, this is a function. Let's just ignore it for now. I'm not going to go over this. But this is where I would interact with JavaScript. Would be through these.
What do you do over there? After subscriptions equals to, what is that?
This is a lambda function. This is basically their structure. Have an argument, and here's like their body.
An underscore is like whatever.
Yeah, it's an anonymous function. It's when I just want to declare a function without giving it a name. I could, if I wanted to describe it, create it as an actual function, I would do it like this.
Okay.
This a regular function.
What do you have after the dash? Is an underscore or just a white space?
It's an underscore. Oh, is the font too small, maybe?
Nice, thanks.
Okay. Yeah, it's an underscore. This just means I'm ignoring that value because it comes with a first argument here. I'm just ignoring it. I don't want to give it a name.
Okay.
So let me see if everything is good now. Yeah, it seems like it's compiling. Oh, it's not. I'll just start it again. Okay. Now let's see it. Yep. Here's my fetch button. If I click it, should fetch the book. Yes. Yeah. So it worked. You can see it here. It fetched the book. It's some random text from the internet. and it just displays it. So same thing with the actions here. It can time travel. First our model was nothing. Then we dispatched the message fetch book when we click the button. And then when the request was fulfilled, it sent back another message called got book with OK and the text. And then I finally have the text here showing. And I think that's pretty much it. Pretty much what I wanted to show. Do you guys have any more questions in the code or anything?
I have a question.
Okay, right.
Okay, so my question is, I like this introduction to Elm. However, we don't use vanilla JavaScript without a framework to do our jobs, because that would take so much time to introduce so many of the things that we need to use on an everyday basis. Is there any framework that supports this Elm language that we can leverage with?
So I'm not sure if you saw the beginning of the presentation, but one of the things I tried to explain was how like all these solutions that these frameworks bring to us, like Redux with the idea of having centralized our state in one place and having declarative ways to update it and updating it through pure functions. With React, we have then components and we have like mappings of state to markup. All these ideas, they were all designed into Elm. So Elm is a full solution, can't say it, a full solution on its own. It could be called a framework on its own. So you won't need to install anything else because Elm is built specifically for the web. And you actually can't use it anywhere else because it's runtime, it's everything built specifically for the web. Of course, you have a lot of packages that you can install, but usually they're very like complementary, and they're all, most of the ones you'll need, like the one to parse JSON, to decode and encode JSON, the HTTP module, all these modules, they're official. So they're kind of like part of the language, but they just don't come installed. But no, you won't need a separate framework or anything. The Elm would be the framework itself.
Okay.
How do you interact with, let's say, the browser APIs? If you need to stream audio or do something with anything, all those more low-level geolocation, I don't know, those type of things.
Mm-hmm.
Can you interact from Elm with those APIs?
Yeah, so for that, I would need to use subscriptions. And not subscriptions exactly. Subscriptions you use when you want to get values from JavaScript, but I can interact with it. Maybe let's just try to show it really quick here. And create new article ports. And in this file, so let's just call it, yeah, module ports, exposing this everything. And then we'll have our function here. I don't know what it's going to do. Let's just call it do thingy. And it takes a unit type. So this is kind of like a void. This is like nothing, a constructor that doesn't carry a value. And returns a command message. This. No, it's going to import it. Yeah, so let me do this in the main module. Otherwise, I'll have too much work. Let's just call this import module, and I'll have do thingy. I'm not sure if I'm going to get this right, just from remembering it, but it's something like this. You basically just declare the type of that function, and then in your JavaScript, you can just create like a JavaScript module. Just delete this. You just create a JavaScript module, and here I'll like import main Elm, something like this from name.elm. And I'm gonna have that function here, so I will do like something like do thingy, subscribe, and then it's basically a callback.
Hey,
And then
Renan,
here I can do my thing. So just a second, just a second to finish this. So this function here, I can dispatch it as if it were a regular function in Elm, and it's going to return a comment. So it's I can create like a new, could just call it here, for example, passing this nothing here, this unit type. So this would send this message to the Elm runtime. It would find a subscription with the same name, and it would invoke this function here. So I could do my my impure thing like reading the DOM, using a browser API, and then I could send it back with a subscription, something like do other thingy if I had a function and send something. That's basically how it would work. It's probably not going to compile because I'm probably forgetting something, but yeah.
No, but this gives me an idea.
I have a question, maybe because I lost like the beginning of the talk. So why would you use Elm instead of just JavaScript? Maybe, I mean, if maybe the main difference that I see with JavaScript is that you can add types over here. But if you use TypeScript Flow or something like that, you can actually type JavaScript. Why would you use Elm instead? What is the main benefit?
So in comparison to TypeScript, I also have worked with TypeScript before in a pretty large application. And honestly, although I like TypeScript and I think it solves a lot of problems, it's not a perfect solution. First, because it doesn't really tackle the fundamental problems of JavaScript, and you can still just like cast things around, and eventually you have to like tell TypeScript yourself that, hey, do things like this. Say this is an object. Let's say this is TypeScript, okay? I can do like, say this is unknown, and then I can cast it back as, I don't know, like a number, and TypeScript will just believe this. And I know it sounds silly when you look at this, because I know why would you do this? But this means that sometimes in TypeScript, especially if you're interacting with packages from outside or values that you're just saying, hey, this is something, it really just, you might get the wrong value. And a lot of times the static typing will fail in that sense. And it will fail not because of types itself, but because it's not a pure function, a pure language. So it doesn't have those same assurances as a pure language has. And at the same time, there are the other benefits I went over, like performance and the semantic versioning of modules, and the small asset sizes.
The error messages are quite good as well.
Yeah, the error messages are pretty good. Just show one here.
Yeah, but you're still using JavaScript work here. It's not that you're not using it at all.
I think, just my personal opinion, in languages, I mean, you can have Elm and JavaScript. It's not a competition. It's not about who wins, JavaScript or Elm. Are different tools for different things, and you can have them both in your toolbox.
Yeah. Yeah. So yeah, exactly. For example, if I was to build something that had a lot of direct interaction with the DOM and with browser APIs, I wouldn't bother writing it in Elm, because like most of the application would be, entangled in all those APIs and things, and it would just be a lot of work to build it in Elm. But Elm, on the other hand, just makes a lot of sense for regular applications that we have, that we usually built with React, for example. We have a web page, we have routes, we have just loading data from different sources. I don't know, forms and everything. That's where Elm succeeds and makes sense. Although people have used for some other different things, like I've seen some people using it for games, for parsers, for also data visualization, but its main focus is really on simple web applications. But it can do everything we can do with React.
In your experience, what are the pain points of the language? I think things that are not so pleasant or good about it.
Mm-hmm. So I wouldn't really say that they're pain points because they really didn't. I wouldn't say that they hurt me like when I was working with Elm. But in this part here, where I mentioned that Elm is a language without this, although it makes it very easy to get started with and to learn, it makes the language a little less expressive than a language like Elm or PureScript, because they're really toning down their type system in order to get this. For example, if you know of type classes in Haskell, you realize right away that Elm doesn't have type classes. So there isn't like a higher order version way for you to describe how your types behave. You can't say, well, it's hard to explain without really going into type classes. But basically, Elm's type system is not as expressive as it could be, and it's intentionally so people can won't have a hard time learning it. And other thing about pain points, I would say that, as I said, when you have a lot of interaction directly with the DOM and just browser APIs, if most of your application depends on that, and Elm doesn't support that out of the box, then it's probably not worth it building an Elm. And I had some rough moments with working with maps, with Google Maps, in the website I worked before. And because Elm doesn't have like a Google Maps package, so we would just use the standard Google Maps API with ports, and it makes their life a little bit harder. And on top of that, the other issue is that like they have this idea of kernel modules that are modules that can be just directly imported in Elm, and they work like any Elm module, but they're written in JavaScript. And these are the modules that they use to communicate directly with browser APIs. The problem, however, is that Evan, the creator of Elm, and some other guys, they just decided that this is not publicly available. So they're the only ones that can develop these modules. Even if you do develop one of them, you won't be able to publish it. So yeah, this I would say is one of the pain points. Although most of all the modules that they have and they created, they work pretty good. They work pretty well, and I know they have a reason for this. And if you look sometimes at NPM, although they have so many modules for everything, there are many modules that just don't work as expected, and they have a lot of power over your application, and they probably didn't want that, and that's why they are so restrictive about it. But again, as I said, I think although Elm is a step above what we currently have and mostly use, I think it's not the end, and it's not perfect, and that's why I would still say that a language like PureScript would still top Elm in that sense, although it's harder it has a steeper learning curve. But I think Elm is a very good place to start, especially with functional programming. And yeah, that's what I wanted to say.
What you mentioned about the modules on JavaScript having errors, I mean, that also talks about the big community that JavaScript has. I don't know about Elm. This is the first time I see Elm in my life. But if the code doesn't have like community to support it, doesn't really matter how good it is. It's not gonna succeed. I don't know. I should probably check, but when you mentioned that about JavaScript, it's like good and bad at the same time, because also you just have to think that because of that, there's a lot of devs creating a lot of libraries, a lot of new versions of the libraries, and yeah, I don't know.
Yeah. Yeah, no,
that's a big
I get.
discussion.
Yeah, that's a big discussion, but I wouldn't really measure. I mean, some years ago, I would say that Elm was not baked enough, not really ready for production. But from my honestly, from my personal experience with Elm, I think it's very mature now, and you have everything you need to build like a standard application without running too many problems. And about the size of the community, I think it's completely expected. I actually think that Elm, for a functional language, it's pretty popular now. It's getting pretty popular, and it wasn't adopted by like any major or created by any like big company, and so I think that explains a lot of it. And still, one of the companies that adopted it was No Red Ink. That's the company where where Evan works, and also Richard Feldman. That if you do some digging, you see that these are the guys that talk most about Elm, and they're the ones that work directly with it. So yeah, I wouldn't really measure like a tool's success by its number of stars on GitHub. For example, I'm not saying you guys do that, but I know that some people seem to do. So that really doesn't bother me about Elm, because from my personal practical experience, it was a very good experience, and it worked as I expected, and even it went above my expectations actually. So yeah, I think that's what I had to show, guys. These are my main resources, not resources that I used in this presentation, because I used a lot of things and I just wouldn't remember all of them. But if you want to learn Elm, I think these would be the places that would go. So the guide of the language, it's official. You have everything you need to start with it there, not just to start, but to build a whole application. The Elm language website has some cool information just for you to get to know it. And there are these 2 talks here that I think are very important if you want to get serious about Elm. And we'll also explain a lot to you if you're coming from JavaScript, and how to get used to it and how to get started. Because if you do get started with it, you see that you have a lot of vices from JavaScript. You'll try to bring into Elm that just won't work the way you expect. So that's it.
Right.
Right.
Thanks a lot, man. Amazing. Great talk.
Thank you.
Bye-bye, guys. Thank you.
All right.
Congratulations.
Good one,
Bye.
everyone. Bye-bye.
Bye.